4.1 talks about related rates. So here we're going to start setting up word problems, and we pretty much have two types of them. We have a type of word problems that you're given an equation, which makes life a bit simpler. And you have the other type of problems where you really have to come up with the equation on your own by what you already know about the geometry of the figure or the description of the problem. So in this problem, they say if two electrical resistors are connected in parallel, you're not responsible to know what that means. When you take physics, you're going to pick all of this up. The total resistance, that's R. That's the total resistance. And this is resistor 1 and this is resistor 2. Is denoted by the Greek letter, these are the total resistance, and these are in ohms, denoted by the Greek letter omega, is given by this equation. So they gave you the total resistance of those two resistors connected in parallels looks like that. If R1 is increasing at a rate of 0.5, so let's see. If resistor 1 is increasing at a rate of 0.5 ohms, that's what the measure of the resistors are, ohms. When it says per minute, so this is a change in resistor 1, and since it's minutes with respect to time. And R2 is decreasing at a rate, the change in R2 is, if increasing we say it's positive, decreasing is negative 1.1 ohms per minute again. So this is changing with respect to time. Every 1 minute it's losing one resistor, 1.1 ohms. At what rate does the total resistance change? That R is changing at what rate when R1 is 20 ohms and R2 is 50 ohms. So they're checking the change of the total resistance when R is 20 ohms and R1 is 20 ohms and R2 is 50 ohms. Initially, the equation is right there. They gave us the equation. And if you really think about it, this says, if I bring it up, otherwise I have to use quotient rule on those 3 times. Now, to get d dt, I notice that everything is changing with respect to time. I take the derivative of those resistors with respect to time. And since t doesn't match r, these are all implicit differentiations. Here we bring the power down, subtract 1 from the power, subtract 1 from the power, by the chain rule dr dt. Here we bring the power down, subtract 1 from the power. Okay, I'm saying it, but I'm not doing it. When you subtract 1, minus 1 is negative 2, dr1 dt. And here you bring the power down, so that becomes a negative. R sub 2 to the negative 2 dr2 dt. Now, my goal is to find dr dt. If they're all negative, I could divide by a minus 1 and make all of them positive. Dr dt will simply be, if I really write this properly, that's dr1 dt divided by r sub 1 squared plus dr2 dt divided by r sub 2 squared all over. I'm going to divide by this, actually not divide. And if I cross multiply, I'll get the change in the total system is r squared times dr1 dt divided by r sub 1 squared plus dr2 dt divided by r sub 2 squared. Now, I have what I need, which is this on one side, everything else on the other side. the change of r with respect to t equal r squared, I'll get in a minute. dr1 dt is given to be 5 ohms and r sub 1 squared is 20 plus dr2 dt was negative 1.1. That was a 0.5, not 1.5. There we go. Divided by r sub 2 squared, and r sub 2 is 50. Now, I need to figure out what r is. Well, come back to the original equation, which is this. If I take 1 over r equal 1 over r sub 1 plus 1 over r sub 2, if they gave me that r sub 1 is 20, r sub 2 is 50, then I know that 1 over r is over 100, 5 times 5 times 2 times 2 times, that's 7 over 100. If I take the reciprocal of this side, that will be the reciprocal of this side. So r is 100 over 7. Now, I could throw all of this in a calculator. You could leave your answer like that, but I need the units as the last stage. That's going to be in ohms per minute. Now, I could plug all of this in my calculator one shot. Not an issue. Here we go. I could say take 100 divided by 7 and square it. Multiply that by 0.5 divided by 20 squared, which is 400, or just put 20 squared, whatever you like, minus 1.1 divided by 50 squared. Again, you could put the value to 2500 or simply 50 squared as you see it. Close parentheses, and my calculator says it's 81 divided by 490. Or simply, if I want the decimal, 0.166. And there it is. So here they gave us the formula. We just used it. We didn't have to do much. Whoa, what happened? Hold on. Okay, we're back. I was trying to get this, and it hit something else by mistake. Come on. Here we go. All right. Here's another problem. Here they didn't give us an equation, but a description will do. They say a 25-foot ladder is leaning against a wall. We have a wall, and the ladder is leaning against it. Now, anything that's standing up forms a 90 degree with the ground, so the wall. If it doesn't, they have to tell you that. The ladder is right there. Now here, this ladder is fixed. The length of ladder is 25 feet. That's not going to change. It's now, just to make things simple, anytime you're talking about horizontal, call X. Anything that's vertical, call Y. And this way, you know, we deal with X and Y like we normally have been doing, and that's what we've been training for all of these years. So if we push the ladder toward the wall, that's the change in X with respect to time at a rate of 1 foot every 1 second. Now, if this is the rectangular coordinates, if this is positive, isn't this negative? And the bottom of the ladder is initially 20 feet away. So initially this is 20 feet away from the wall. How fast is the ladder moving up? When you push this inwards, obviously the ladder will start pushing up. So that's dy dt. That's what we're looking for. So we want to know the change in the height of the ladder is what when 5 seconds have passed. Well, let's see what happens. Now, how am I going to correlate those? I have 20, y, and x. Isn't 20 squared equal x squared plus y squared because that's a right triangle? So Since I want the change with respect to time, I'm going to take the change of rate with respect to t. Derivative of a constant is 0. This x and this y don't match implicit. Bring the power down, subtract 1 from the power dx dt. Bring the power down, subtract 1 from the power dy dt. Now, what am I looking for? I'm looking for dy dt. I want that by itself. I could divide by 2 and get rid of those, or that will simplify by itself later. So I'm going to move this over. Negative x dx dt equals y dy dt. And I could say dy dt will equal negative x dx dt divided by y, or simply x over y, whatever you want. So I know that dy dt will equal, and let's see how that's working. I have 3 variables, one of which I know for sure. Dx dt, I know that's a negative 1 foot per second. I need to know what x is, and I need to know what y is. Well, let's see. X. Initially, I was 20 feet away. Initially, this was 20 feet. I'm moving in at a rate of 1 foot every second. In 5-second time, wouldn't I move in 5 feet? That means the distance x now is 15. If this is 15, and this is fixed to be 20, can't I figure out why? Can't I say 20 squared, which is 400, equals 15 squared, which is 225, I believe, plus y squared. So y squared is 175, and y would be the square root of 175. You could leave your answer like that on a test, except you have to give me the units. Now, y and x are moving at the same rate. If x is moving at feet per second, this is moving at feet per second. If you want to match the back of the book, you get your calculator out. Negative times negative is a positive. 15 divided by the square root of 175. That's simply 3 radicals. Again, you're going to give me a decimal. It's roughly 1.13. So the ladder is climbing the wall at a rate of 1.13 feet every second. It's moving faster on the wall than the pushing in at 1.1. Next problem. You and your friend are riding your bikes to a restaurant that you think is east. So anytime you talk about you and your friend are riding your bikes to a restaurant that you think is east. Your friend thinks it's north. You leave from the same point. You leave at the same point. You are heading east. Your friend is heading north. You both leave with you riding at 16 miles per hour east. So the change of your distance with respect to time is 16 miles per hour. Your friend is heading north at a rate of 12 miles per hour. All right. After you traveled when x after you traveled when x equal 4 miles, at what rate is the distance? Call the distance between you z. At what rate is the distance changing? Notice the distance between you two is right there. Call it s, but I'm going to stick with z. I like z. Here we also know that this is a right triangle, and I could say that z squared equal x squared plus y squared is the equation that combine those 2 variables or 3 variables together. And since everything's with respect to time, and that's how it's going to be in this entire section, if I take a derivative with respect to time, that's 2z dz dt equals 2x dx dt by implicit differentiation, 2y dy dt. They all have a 2, I cancel them out. I'm looking for the change in the distance with respect to time. If I get that by itself, I'm done algebraically. But now I need to fill in the blanks. I need to know what these points are. dz dt, let's see how we're going to find all of them. I have 5 values to fulfill, and I'm done. Well, let's see. X is 4 miles. They told us that. That's simple. Dx dt is 16. We know. Y, I'll get that in a minute. Dy dt was 12. And Z, I'll get in a minute. Now, I am moving along. I drew that a bit out of sync. Okay, there we go. So, I am moving east. They said X is 4. If X is 4, how much time has lapsed? Remember, I'm covering 16 miles every 1 hour. I'm covering 16 miles every 1 hour. I covered 4 miles. Isn't that 1/4 of this? So that should be 1/4 of an hour. So if I'm moving at a rate of 60 miles per hour, each hour I'll cover 60 miles. If I only covered 30 miles, then I must have traveled half of the time, which is 30 hours. And if I only covered 15 miles, that's a fourth of the 60, which means that's a fourth of an hour, 15 minutes. So we know that 1/4, by covering 4 miles, we know 1/4 of an hour have lapsed. Your friend is moving at 12 miles per hour. In a quarter of an hour, they would move a fourth of that. A fourth of that is 3. So if they moved 3, the distance between you is 5, because that's a 3, 4, 5. Again, you could figure out z squared equal 3 squared plus 8 squared and go from there. Now you could leave your answer like that on a test again, but what I want is the units. The units for z, which is distance, is identical to the sides, which is miles per hour. mph will do, miles per hour will do. And of course, you can plug this in a calculator or do it by hand, whatever makes you happy. So if I take 4 times, parentheses, 4 times 16 plus 3 times 12 and divide that by 5, it's 20. So the distance at that time is increasing at a rate of 20 miles every 1 hour. Again, mph or m divided by h will do. Number 14, a helicopter starts on the ground and is rising directly in the air. So the helicopter is going straight up. Oops, let's make that a bit nicer. So the helicopter is going straight up. If this is y, the helicopter is going up at dy dt. Helicopter starts at the ground and rising directly in there at a rate of 25 feet every second. You are running on the ground, starting directly under the helicopter. This is you. At a rate of 10 feet per second. Let's say you're running this way. If this is x, your rate is 10, not 5. 10 feet every 1 second. Find the rate of change of the distance between the helicopter and yourself. Call that z. So we're looking for dz dt equal when 5 seconds have lapsed. Well, let's see again. We know that z squared equal x squared plus y squared. And we notice everything is with respect to time, so we take d dt of both sides. 2z dz dt. So hopefully you're getting better at seeing this and doing this. And as you see, I could divide by 2 both sides, cancel all of those. I am looking for the x dz dt, so the usual. By now, hopefully, you're really comfortable with that. dz dt would be x dx dt, very similar to the previous problem. Pretty much the right triangles are very close. The only catch, sometimes they play with the angle instead of the sides. So we know that dz dt, actually let me move underneath. dz dt will be, again, 5 values. Let me see if I could figure those out. Well, let's see, what do we know? We know that the dy dt is 25. The plane is going up at a rate of 25 feet every second. We know that you are running at a rate of 10 feet every second. Well, let's see. You start right there. In 5-second time, you're moving at a rate of 10 feet every 1 second. In 5 seconds, you moved 50 feet. That's x. The plane is rising at a rate of 25 feet every 1 second. In 5-second time, it moved 125 feet. And the distance between you at that one time is z squared equals 125 squared plus 5 squared. So z equals the square root of that. What is that, by the way? I want to check. What is 125 squared? Oops. What's 125 squared plus 5 squared? And if I take the square root of that answer, is that a whole number? No, it's not. Okay, so that is, oh boy, that is the square root of 15,650. 15,650, if I didn't make a mistake. So basically, the square root of 15,650, you could leave the answer like that on your test. You just have to give me the units. Since everything is in feet per second, there you are. You could plug that in a calculator. And you notice we have 50 times, again, parentheses, 50 times 10 plus 125 times 25 divided by, and I just hit answer because that's the last calculation I did, and it's 28.98 28.98 feet every 1 second. And there it is. And these are the first type of problems. Here's another problem. The following for the following exercise, draw diagram to help yourself. Here, they're not going to give you the equation. Now, if it's a prism, I provide the formulas. If it's a non-prism, you figure that out. A prism is when you take a figure, and if you cut parallel to the base, you get exactly the base. In those, volume is area of the base times the height. That you're responsible to know. But if we're dealing with a pyramid, if you're dealing with a conical, if you're dealing with a sphere, I provide the formulas. You need to memorize those. You just have to memorize the formulas for the prism as far as perimeter, area, and volume, or perimeter, surface area, and volume. Here, we have a cube. We have one of those. So that's a prism. If we call this x, this is x, and this is x, that's what's so special about a cube. All the sides are equal. They say the sides of the side of a cube increase. If the side is x, increase at a rate of, notice it's in meters per second. So this is in meters, and seconds is time. It's increasing half a meter every second. In case you don't know, a meter is about 3.3 feet. So this is expanding quickly. That's a lot. That's roughly, 1.5 foot every 1 second. All right. Find the rate at which the volume. We're looking for how fast is the volume increasing when the side of the cube when x equal 4 meters. So those go hand in hand. This volume is going to expand. In the beginning, it's going to expand very fast. As time passes by, it's going to start slowing down because the volume is getting bigger. Well, what is the volume of a prism? Volume of a prism is area at the base, x times the height. So basically, it's x cubed. And since there's only one unknown, I'll take a derivative of both sides with respect to t. I'll get dv dt equaling 3x squared dx dt. Well, this looks straightforward. It is straightforward. dv dt will be 3. I need an x, I need the x dt. Well, I know x is 4, and I know the x dt, squared, is 1/2. Again, I don't mind you leaving the answer like that, but you have to tell me the units. If a side is increasing at a rate of meters per second, volume will be cube that per second. And you could plug this in a calculator and give me that as an approximation. You could do it by hand. This is 16. Half of 16 is 8 times 3. That's 24 cubic meter every second. It doesn't matter how you write the answer. To me, all of these are the same on a test. No need to really simplify any of those. Next problem up. The radius of a circle. We have one of those circles. There we go. And of course, a circle depends on the radius, whether you're dealing with the perimeter / circumference or the area. And the area of a circle is pi r squared, and the circumference is 2 pi r. The radius of a circle is increasing. So the change of the radius with respect to time is a positive 2 meters every second. Again, that's pretty fast. That's almost 6.6 feet every second. Find the rate at which the area, how fast is the area changing when r equal 5 meters? Again, the 5 meters go with the change of area. Keep in mind, in the beginning, the area is going to be getting bigger and bigger very, very, very fast. As you move outwards, it's going to slow down, because if you're pouring in, if the radius is growing at a rate of 2 meters per second, the circles are created very fast in the beginning. As they get bigger and bigger, you're going to slow down on how fast they're going to expand, because the radius is changing at a fixed rate. Well, how do I correlate an area and a radius? I know area is pi times the radius squared. And since that's the only unknowns I have, I take the change with respect to t. The change of area with respect to t will be, bring the power down. Remember, pi is a constant, dr dt. Basically, nothing to do. Just plug them in and you're done. 2 pi. The radius in this case is a 5. And the change of r with respect to t is 2. You could leave the answer like that, I don't mind, but you have to tell me the units. Area will be square those units. And of course, that's 20 pi. You want to approximate that, you can. I wouldn't know why. There's a valid answer. It's exact. And 20 times 3.14, 60 point some. Again, you could use a calculator and figure that out if you need. Let me just adjust these problems really quick.